Okay, so we've got a body of mass 5 kilograms falling under gravity, and it says it reaches a terminal velocity v downwards. Given the body experiences a resistance force of 0.04 v squared, where v is the speed of the body, determine v and find the time taken for the body to reach a speed of 4v over 5. So there's the force diagram here. Okay. But first of all, they mentioned about terminal velocity is v, yeah? Okay, now terminal velocity simply means the final velocity that the body reaches as it's falling, so it can't get any faster, okay, and it stays at that speed, okay, essentially. Now if it stays at that speed, we can say at terminal speed, the speed remains constant, okay? So terminal speed, the velocity remains constant. So in other words, v is the same, so the acceleration will be 0. Now in that case, if the acceleration is 0, okay, when you apply Newton's second law, okay, the resultant force will equal 0. Which means you've got the 5g, take away the 0.04 v squared will equal 0. Okay, and therefore your 5g will equal to 0.04 v squared. And you can work out v squared from there. So v squared will equal to 5 times 9.8, the value for g, divide by then 0.04. So v squared turns out to be 1225, which means v then is 35. Okay, so in other words, its terminal speed is 35 meters per second. Okay, its final speed. It can't get any faster than that. And that's when the forces were balanced. The up forces were balanced with the down forces. And we've balanced them, so we've been able to work out v there to be 35. But it says then, find the time taken for it to actually reach 4/5 of this terminal velocity. So 4/5 of v, okay, or 4v over 5, will simply be 4 times 35, divided by 5. And if I do that, it comes out to be 28 meters per second. So find the time taken for it to actually reach 28. So we need to form a differential equation, and we're going to apply Newton's second law, okay, to it in the direction of motion. So we've got 5g going down, take away 0.04 v squared, and that will equal, the resultant force will equal to mass, which is 5 times acceleration. Now of course it's still going to be accelerating, isn't it, when it gets to 28 meters per second, because it hasn't got to its maximum speed yet. It hasn't got to its terminal speed. Okay, so it's still accelerating at that particular stage. So when you've got this here, what I would do now is think about getting that v squared to be, or getting the number in front of that v squared to be 1. Okay, that's what I would do there. So in order to do that, all you need to do is just to divide through by 0.04. Okay, so if you do that, divide through by 0.04, you will get 125g here. That will just become v squared then. And when I divide 5 by 0.04, I get 125 here as well. Okay. Put in the value of g, so 9.8. And that comes out to be 1225 minus v squared is 125a. Okay. Now of course then we can say, look, a is dvdt. So I get that. We then separate the variables. Okay. So keep the 125 where it is, take the dt up, put the 125 outside because it's a multiplying, multiplying by it, and you take the constant out there and you get this. Now on the bottom there, we can apply then standard integral, and again it just goes back to the one we've used previously. This one here, a squared take away x squared, is that. Okay, the question is, what is 1225? Okay, you're squaring something to get 1225, and that will be quite simply 35. Okay, 35 squared is 1225. Okay, so you can just check, square root of 1225 is 35. So integrate this, you get t, you get 125 here. Using that result then, so we've got 1 over 2a, so 1 over 2 times 35 ln 35 plus v, 35 minus v. Okay, now again, you can, if you want to, you can put plus c now. Okay, or you could put the limits here. Okay, because it is released from rest. Yeah. Okay. So, and it says find the time taken for it to reach a speed of 4v over 5, which of course was 28. So you could put limits in there from 0 to 28, okay, to save having to go through the constant bit. It's your choice. So when I simplify that in here, I get 25 over 14 ln of 35 plus v over 35 minus v between the limits of 28 and 0. Okay, plug in the limits and you get your time out to be 3.92 seconds.